Alright guys, so today we're going to be doing the quotient rule, and that is going to be used to compute the derivative of expressions of this form. You could have, for example, a rational function, like so. You can compute now the derivative of that by using the quotient rule. Before, we were unable to do that, so this is going to be a very useful rule to take derivatives. The other type of expressions you could have would be something a little bit more exciting, let's say. Something like that. You could take the derivative of that as well. And let's take a look at how it works. So here, my function f will be x plus 3. My function g will be x minus 1. So I have to take the derivative, and we're going to write it all out. The derivative of x plus 3 times g, which is x minus 1. So derivative of the numerator, or some people would say derivative of the top, times the denominator, or the bottom, minus, now you're going to copy the numerator and take the derivative of the denominator, which is going to be x minus 1. All of it over the denominator squared. So that right there is going to be applying the formula as it's written. So now it's just a matter of taking the derivatives and trying to simplify as much as possible. So in this case, derivative of x plus 3, derivative of x is going to be 1. Derivative of 3 is 0, so just 1 for that whole derivative, times x minus 1. You just copy that one, minus x plus 3 times now the derivative of x minus 1, which again is going to be 1. Derivative of x is 1, derivative of 1 is 0, so just times 1, all over x minus 1 squared. And now here, I'm just going to try to distribute everything that I have. In this case, it's just negative that I have to distribute. So it's going to be negative x, or minus x, minus 3. And here we can just cancel like terms. As you can see, this x will cancel with this x because one is adding, the other is subtracting, so they cancel out. I get negative 1 minus 3, negative 4, all over x minus 1 squared. And just like that, you get your derivative. Some people like foiling this bottom, or this denominator, out. I don't find that to be too convenient. In fact, whenever you're going to take second derivatives, as we're going to do later on, maybe we'll do that here in a minute, not foiling it out will actually be convenient. The second derivatives, I should say, we'll do after we introduce another rule, which is going to be called the chain rule. At the moment, we're just going to do one derivative at a time. So let's take a look at this one right here. So if we apply our formula, we need to take the derivative of the numerator. So the derivative of this numerator is derivative of the sine, which is cosine of x. That's going to be your f prime, times g prime. So we normally prefer to put the x in front of it, so that would just be your g. So I wrote g f prime minus, now derivative of the bottom, that's going to be your g prime, but in the order we have it written, we are going to just copy first the sign. And so times the derivative of the bottom is derivative of x, which is 1, so we just need to now divide by x squared. And that right there gives you your derivative. So that one turned out to be quite easy. Some people will distribute the x squared and write this as cosine over x minus sine over x squared. You don't need to do that. This is perfectly fine. So let's do one more or two more examples of the chain rule. That thing wanted to fly away. We let it fly. Now we pick it up. So let's take a look at another one of those. So let's do, for example, e to the x over, and let's do some x squared plus 2x minus 1. Something like that. I'm going to keep writing down here because I'm not going to have space if I try to write it in line. So let's write that derivative here. Derivative of the numerator. Remember, the derivative of the numerator here is just e to the x because e to the x is its own derivative, so that's that, times the denominator minus, copy the numerator, which is another e to the x again, times the derivative of the denominator. Derivative of x squared is going to be 2x. Derivative of 2x is going to be 2 all over the denominator squared. And here, the only thing we need to do is factor e to the x. And so we get x squared plus 2x minus 1, now minus, parentheses, 2x plus 2. So I just took the common factor e to the x out on both, and I get x squared plus 2x minus 1 squared. And I just remember a very common mistake that I'm going to warn you about so you don't make that mistake. So I'm not going to write it because it would be misleading, but I'm just going to show you what people tend to do. So they look at an x squared plus 2x minus 1, and they look at an x squared plus 2x minus 1 here. So people say, well, I cancel this guy, so one of them, with this guy here. But you got to be really careful, because this term right here on the numerator is not multiplying the entirety of the numerator. So you cannot cancel just one of them. So that would be a problem. If you wanted to cancel like that, you would have to then distribute the denominator and write this term separately. But don't do that. So that's a temptation that happens, but don't do it. That would ruin your problem. You would get it wrong after that, and you don't want to do that. So in this particular case, then what I have is x squared. Then I look at what I have for the x's. I have 2x minus 2x cancels, so nothing there. And then I get minus 1. When I distribute here, I get minus 2. So let's write it out. All over that. And then I can go ahead and just write this as x squared minus, do I have room there? Probably not. Barely. So minus 3, and then divided by this denominator square. I'm going to rewrite it so you can see it in the screen because it got cut off. So let's go ahead and rewrite it one more time so you can have it available and you can verify your answers if you decide to work alongside. So let's take a look. Let's write it out. And that's going to exemplify for us the chain rule. The chain rule is very straightforward to apply. Couple things you have to remember. It's minus, it's not plus. In our product rule, we had a plus. So in the quotient rule, it's a minus. And then the square. Sometimes even when I'm doing examples, at times I forget the square. So don't forget that square. That's one that I've seen that can cause trouble. The other issue is you're always going to have a factor that in the denominator that will look like the numerator, and they don't cancel unless you can factor it all out and get it to be a common factor. So be very mindful of those things. Other than that, it's just applying the formula and your derivatives. Should be pretty straightforward. So we'll leave that quotient rule at there, and we're going to start looking at the chain rule in a minute. All right, so I did change my mind. So I'm going to give you one more example, and it's just to illustrate one aspect that is useful when you're doing the quotient rule. So let's imagine that we have this expression here. X squared minus 4x plus 3, for example. And then you would have an x minus 1 in the denominator. So if you have that situation going on, you may just say, okay, fine, I apply my, my quotient rule. And let's go ahead and do it, just because it's more practice and it's good. So let's go ahead and write that. We may not have enough room in line, so let's go ahead and write it here. So derivative of the top, and I'm just going to write the derivatives. The derivative of numerator, 2x minus 4 times x minus 1, which is the denominator, minus then derivative of the denominator, which is going to be 1, times the numerator. So just doing g prime, which is 1, times f, which is x squared minus 4x plus 3, all over the bottom squared, which is x minus 1 squared. And then you do some algebra. We're going to FOIL the first expression out, and we get from that, I don't need the parentheses, well, I wrote it now, so it doesn't matter. So 2x squared, and then I'm going to have minus 2x minus 4x plus 4 minus x squared minus 4x, sorry, I dropped the 4, plus 3, all over x minus 1 squared. And then you would cancel, and you get 2x squared minus x squared is x squared, collecting like terms. Here I get negative 2x minus 4x is minus 6x minus negative, so plus 4x, minus 6x plus 4x minus 2x. And then I get a plus 1 minus 3 is, sorry, plus 4 minus 3, I gave you the answer, a plus 1. Because I know what's coming. That's how I wrote it. And notice that you get x, factor. If you factor, this is a perfect square, so you get x minus 1 squared over x minus 1 squared. And provided that x is not equal to 1, we have that the derivative then is 1. Of course, x equals to 1 is not even in the domain of our original function, so we can cancel there with impunity if we want. And that's going to give us that the derivative is 1. That is remarkable. But why is that? Well, if you would have, instead of done what I did and just applied the formula without thinking twice about it, and if you would have factored ahead of time, you would have noticed that this is going to be x minus 1 times x minus 3 over x minus 1. So whenever x is not equal to 1, you get just the derivative of x minus 3. So now you don't even need a quotient rule. You just take the derivative, and that gives you 1. So you see, we did it in two different ways. One was way simpler than the other. So that is just to remind you to, if you have a rational expression, try to simplify first. And I sound like I know all the answers, but let me tell you, I wrote this example before. I solved it, I got 1. I was somewhat surprised, and then I realized what I had done. So you don't make the same mistake I made. Simplify first. So that is where we're going to cut it here for quotient rule. All right, see you guys in the next video.